Welcome back, geometry folks. We're moving on our unit in polygons. We're going to start talking about parallelograms. Yeah, because they're kind of fun. So before we talk about what we're covering today, just a reminder of what we're going to be getting in through the entire unit. We will start talking about quadrilaterals in general and getting all into some crazy stuff. And what we've covered so far is the angle sum theorems with different polygons. So we talked about that, and we're going to get into parallelograms. So what are we going to learn today? We're going to learn about consecutive angles, consecutive sides, properties of parallelograms, and we're going to be using algebra, parallel lines and transversals, which is like this totally random thing we're going to get into. But well, let's get started with notes. So there's a whole bunch of notes on parallelograms. I'll talk about each one very briefly. Basically, if a quadrilateral, four sides, if a quadrilateral is a parallelogram, then opposite sides are congruent. So you got to know what opposite sides are. Okay, opposite sides and opposite sides. So we got to know what opposite sides are. So if we have a parallelogram in play, that means the opposite sides are congruent. Next note, if a quadrilateral, four sides, is a parallelogram, then consecutive angles are supplementary. We got to know what the heck consecutive angle is, right? So if this is angle A, a consecutive angle is angle D, right? That is a consecutive angle, and they are supplementary. However, also the case, if we have angle A consecutive angle is angle B. All right, so those are also consecutive angles. Notice how they're right next to each other. Those are consecutive angles. So if a quadrilateral is a parallelogram, consecutive angles are supplementary. Make sure you understand what consecutive angles are. That's a key element. If a quadrilateral is a parallelogram, then opposite angles are congruent. So notice now we have consecutive angles in the previous note. This new note is about opposite angles. So what are opposite angles? They're going across the parallelogram, okay? Those are opposite angles there. And similarly, opposite angles are there. So if opposite angles are congruent, we get a parallelogram. And lastly, for parallelograms, if a quadrilateral is a parallelogram, then the diagonals bisect each other. Okay, so we got to know the deal with diagonals. So from corner to corner, we got a diagonal. If the diagonals bisect each other, cut each other in half, wakaw, announcement, and wakaw. Okay, if that's the case,
teachers, the administration staff is starting to check rooms, so we'll be walking around classrooms and checking.
Oh, I hope I get walked in on.
Making sure everything is shut down.
So anyway,
this time we're starting. Here we go.
If a quadrilateral is a parallelogram, then diagonals bisect each other. So that's the case. That defines a parallelogram. Those are good notes to know. We also have a note here. It's like a random thing. It's almost like, hey, since we're talking about stuff, may as well throw this in there. So it talks about parallel lines, multiple parallel lines. Okay, these are all parallel, being cut by transversals. Basically, if one set of segments here is congruent to each other, then all of these segments here are congruent to each other. Okay, so the whole deal, if parallel lines are being cut by transversals, and if we have cut congruent segments from one of the transversals, then the other transversal will also have congruent segments. And so we'll see how that note plays out later, but it's like this random note that's kind of there. You know, if we're talking about parallelograms, may as well bring this up, so they say. But let's get into some work. This set of notes should go fairly quickly. So our first question, we're going to talk about consecutive angles. And our first question is, what is the measure of angle P in blah, 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 PQRS? We've got to know what blah, 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 blah means. That little symbol means it's a parallelogram. So we already know that we're dealing with a parallelogram when we see that symbol, which gives up a lot of information for us. And so what we can do is work with that information. So we have that symbol here, and we know we're dealing with this picture here, and it's a parallelogram. So it's asking, well, what is the measure of angle P? Here, of course, is angle P. And it tells us that, well, this angle over here, angle S, is 64 degrees. So what we have to do is remember the note. If a quadrilateral is a parallelogram, then consecutive angles are supplementary. Consecutive angles are supplementary. That means these two angles together, angle P and angle S, the measure of angle P plus the measure of angle S is equal to 180. So to answer the question very, very quickly, to answer it, of course, we would subtract 64 from 180, and that would give us the measure of angle P. Okay, so all we got to do is that, and you should have this by now, but I'm just now catching up to you. So we'll get 116 degrees would be the correct answer for that. And that's what consecutive angles mean. They're right next to each other. Okay, so let's do another one. More practice now. More practice. So here's another question. Suppose you adjust the lamp so that the measure of angle S is 86. What's the measure of angle R? Well, now we're not giving you much things in the picture. So here's the measure of angle S, right? And we're telling you that that is now, well, what if that was 86 degrees? What would then be the measure of angle R? Well, guess what? Those are consecutive angles, okay? So those are consecutive angles. And as we recall, consecutive angles in a parallelogram are supplementary. Okay, so it tells us it's a parallelogram, therefore, consecutive angles, supplementary. So all we're going to do is subtract 86 from 180. We are in business, and we should get 94. Boop, 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 94 degrees. Okay, so that's how consecutive angles work. Just remember, in a parallelogram, consecutive angles are supplementary. Easy peasy. I don't know what this slide is doing here, so I'm going to fast forward through it. That wasn't supposed to come up. So let's keep powering through, shall we? Oh, it's out of order. So now we're going to talk about properties of parallelograms. And in order to do that, I'm going to show you a proof. Now, I know you're freaking out. No more proofs! I know you're freaking out, but follow the logic here. We can get there because we're talking about parallelograms. So we have this little proof here. It's saying given a parallelogram, ABCD, and AK is congruent to MK, segment AK is congruent to segment MK, we're going to prove angle BCD is congruent to angle CMD. So we've got to figure out what's happening. Well, look at what's going on. We're given that we have a parallelogram A, B, C, D. That's a parallelogram. And what we're trying to prove is that this angle, BCD, is congruent to this angle, CMD. And we know that this whole big AK is congruent to KM. We got to come up with a game plan to prove these two little angles here are congruent. So how are we going to do this? Hopefully you better think about it now before I give it up. So pause, think, and then hit play. So what do we know? We know what's given. That ABCD is a parallelogram, that's given, and that AK is congruent to MK, that is also given. So let's think. We're going to think through this. If AK and MK are congruent, you know what kind of triangle we have? Isosceles. With that line of thinking, if these two are congruent, then we know that this angle is congruent to this angle because of isosceles triangle theorem. Okay, so angle BAD, this angle in here, BAD, is congruent to angle CMD because of it's the isosceles triangle theorem. All right, if the sides are congruent, then the base angles are congruent. So we have those two angles are congruent. Now, remember before when we said ABCD is a parallelogram? ABCD is a parallelogram. And do you remember the notes about parallelograms? When parallelograms tell you if a quadrilateral is a parallelogram, opposite angles are congruent. Opposite angles are congruent. That's defining parallelogram. Well, guess what we know? Opposite angles are congruent. Okay, so we can say that angle BAD is congruent to angle BCD because opposite angles of a parallelogram are congruent. And now we can prove that these two angles are now congruent. How do we know? Do you remember? The transitive property of congruence, folks. That's how it works. Okay, so we can use these properties of parallelograms to deepen our understanding, and that means proofs. Okay, so don't freak out. They're okay. Not going to bite you. Okay, so we can do that stuff. All right, so now let's use some algebra. Let's do some algebra. You're going to see questions that have algebra, folks. Let's just deal with this. So let's use algebra. We're going to solve a system of equations to find the values of x and y in this parallelogram. Okay? So the question is, what are the distances or the measures of the segment KM and LN? So we have all of this funky stuff going on. Now, how are we going to do this? Well, we're going to do a system of equations. But more importantly, we need to know the note. The note is that if a quadrilateral is a parallelogram, diagonals bisect each other. That means we have two congruent pieces here, okay? We got to know that, folks. It's so important. Oh my gosh. So what we know is that this piece LP is congruent to this piece PN, and this piece KP is congruent to this piece PM. Okay, that's what we got to know. It says parallelogram, we got to know that. But now we get into this. If we know that's the case, that we have these two things are equal, we now have equations that we can deal with. Okay, we're saying x is equal to y plus 2. So x is equal to y plus 2. That's what bisect means. And y plus 10 is equal to 2x minus 8. Y plus 10 is equal to 2x minus 8. That's what that means. So we have two equations that pop up out of this little factoid. And now we do some algebra memory. System of equations. So remember we talked about bisect, two equal parts. So bisectors make equations. You got to know that. But more importantly, to chill out about systems of equations. When we deal with system of equations, we want to wonder, is one variable isolated anywhere? Do we have an x by itself or a y by itself anywhere? And if not, can we make that happen? And if we can, if it does exist, then we can use it. If it doesn't happen, then we can make it happen. If it does happen, well, let's use it. So remember the question, is one variable isolated anywhere? Look at our equations, and the answer is yes. Check it out, dude. The x is isolated in that equation. What does that mean? That means x is y plus 2. X is y plus 2. So look at the other equation now. X is y plus 2. Okay, that x is y plus 2. So we can rewrite this second equation a little bit differently. So instead of writing 2x, we're going to call it what it is. X is y plus 2. And so now we have an equation that we can solve in one variable. Okay, so that's the tricky part about systems of equations. The rest is, let's do some distributive property. So now we're going to simplify our equations just like we've normally done in the past. Y plus 10, nothing is happening. But what's happening here? We have 2 times y plus 2. So we have the distributive property at play. Okay, 2 times y and 2 times 2. And then we have our minus 8. Okay, so we use the distributive property. Now we can simplify some more. Okay, so again, we're not doing anything with y plus 10, but we're doing something over here. The 2y is fine because that's the y's, but we have something going on with our 1's. Plus 4 minus 8, that's minus 4. Okay, so plus 4 minus 8 is minus 4. So something happened with our 1's, and now we have an equation that's more manageable, I hope. Right? I hope this is more manageable to you. Personally, I like to subtract my variables first, or undo my variables first. So I will subtract my y first, and I will be left with 10 on the left-hand side. 2 y's minus a y leaves me with just a y, and then minus 4. And then, of course, the last step, we want to add 4 to both sides. And then we can see, hopefully, that y is 14. Now, what in the world do we do with this y equals 14? Let's go back to the question. It says find the values of x and y. Hey, we got y done. Now we got to find x. But then what are the distances? What's km and ln, right? So we have to do some more work. We have found y. What can we do with that y? Now we need to find the value of x. Remember our equation up here? We said x is y plus 2, but y is 14. X is y plus 2, but y is 14. So x is y plus 2. X is 14 plus 2. So x is 16. So we know x is 16. We know y is 14. We have found the value of x and y. But let's read. What are km and ln? Km goes all the way across. Km goes all the way across. So we have from k to p is y plus 10 but we know y is 14, so we have k to p is 14 plus 10. And then we have, well, from p to m is 2x minus 8, but we know x is 16, and so we have 2 times 16 minus 8. Okay, so we can do some number crunching, right? So from k to p is 14 plus 10, that's 24. And if it's bisecting, that's also 24, or we can do the numbers. Either way, we're going to get 24, because of 32 minus 8. So we have 24 there. So we know our distance, km. Right? So we have just found our distance, km. How'd that go? How did we do that? We plugged in what we knew. K to p is 24, p to m is 24. So km, 24 and 24 is 48. So we now know that piece of information. And now what we need to do is find ln. So we find ln the very same way. Okay, so we find ln the very same way. We know L to P is x. What was x? Was 16. So we know x is 16. And we know y is 14 plus 2. So y is 14. So from L to P is 16. From P to n is 16. Well, then from L to n all the way across, 16 and 16 is 32. So all the way across, it all depends on the answer. So look at that complicated question. I love this question. Lots of neat stuff going on. And that's how we use algebra. If any of this was confusing, rewind, do it again. So here's another one. I'm going to do this one a lot faster. Okay, we're going to find the values of x and y in this parallelogram. Parallelogram means the diagonals bisect each other. Okay, boom, 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 boom. They bisect each other. Bisect gives us equations. 3y minus 7 equals 2x. X plus 1 equals y. So let's go do this. Here's our system of equations. We have a y by itself. And now we can use this top equation. So instead of saying 3y minus 7, we're going to say 3y minus 7. Because y is x plus 1. Okay, so notice what happened. The y is by itself. The y is still x plus 1. Y is still x plus 1. Okay? No big deal. No big deal. Distributive property. Combine like terms. Plus 3 minus 7 is minus 4. And by the way, if you have not paused this yet to work it out on your own, do that now, please. Thank you. Pause it and play it back when you're done. And you will see what's happening. I'm going to do some interesting stuff. So clearly x is 4. There's many different ways to get to that, but you will find the value of x is 4. If the value of x is 4, guess what y is? Y is 4 plus 1. So y is 5. Okay, so x is 4, y is 5. Now we just got to do the dealio. So if we know our y is 5, that means SQ is the easier one to find. SQ all the way across here is 10. 5 here, 5 here. That's 10. So SQ is 10. What about P to T and T to R? X was 4, correct? So here we have 2 times 4, which is 8. So that means from P to R, all the way across, we have 8 here and 8 here. That's 16, folks. We can do this. So all the way across, from P to R is 16. So we have the length of our diagonals. Hooray for algebra. Okay? Okay. So you remember that random note that we had talked about at the beginning? Let's use that, right? So if we have parallel lines cut by a transversal, congruent segments here, then congruent segments here. So let's use that. So this random thing is going to come back. This is what the questions will look like. So in the figure here, all of these things are parallel. AE is parallel to BF, to CG, to DH. They're all parallel. AB is equal to BC is equal to CD, and these are all 2, right? So this is congruent, congruent, congruent. They're all 2. EF is 2.25. So EF is here. But before we label it at 2.5, if these are congruent, what do we know? If those 3 are congruent, what we know is that the other pieces are congruent on the other transversal. That means these are congruent. That's the only note, folks. So that's the use of that note. That means those are congruent. And if from E to F is 2.25, That means, well, we have 2.25 here, and 2.25 here, and 2.25 here. That's 6.75. Okay, so what is e to h? All the way across? Just add up. 2.25 plus 2.25 plus 2.25, or multiply by 3, or whatever you're going to do. It's going to be 6.75. That is all the way from e to h. Okay, so that's that simple note at work. Was that too fast? Fine. Rewind. Do it again, or let's do another. Okay? So here's another example. Pause and try this one on your own. This one's a good one. So we have AE is parallel to all these things. EF and FG and GH. EF, FG, GH. They're all congruent. They all equal 6. Not that it matters. But AD is 15. So let's boom, 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 boom. That means they're congruent. From A to D is 15. So those three pieces, those three congruent pieces are 15. What is CD? Right? That's the question. How far is CD? So if those three pieces are 15, then each piece is 3. Well, CD is 3. Ta-da! Nice and easy, right? 15 divided by 3. So we can do this stuff. It's within our grasp. We can totally do it. Just take some practice. So let's do a quick quiz. I'm going to answer these questions super duper fast, and then we'll call it a day. This lesson is already long. So in this particular question here, it's asking what's the measure of angle N down here. Parallelogram, element O. Guess what we know about parallelograms? Opposite angles are congruent. 106. Piece of cake. Next question. How about the one we just worked on? MQ, 29.5. So all the way from here is 29.5, and we know this to be the case. And what is MN right here? What is this? So we have 1, 2, 3, 4 pieces. So all I got to do is divide 29.5 by 4, which would be 7 point, let's see, 2, no, 3, 7.3. I'm doing this in my head. Hang on. 3, and then 7.5. 7.375. Okay, so there. That would be that. We're just dividing that whole big piece by 4. 7.375. That is the distance across. Hope you do. Last one. Oh no, system of equations. How's he going to do this one quick? Solve the system of linear equations to find the value of A and B, and then what's the whole answer? Well, let's look at our equations first. We have this is 2A and this is 3B plus 2. That's an equation. Okay? Saw that? Good. Here is 2A plus 3, and that's going to be equal to 6B minus 1. Okay? Now, how am I going to answer this? Watch this little shortcut. You know what I know? I don't know A and I don't know B, but what I do know is 2A. 2A is 3B plus 2, and there's 2A. So 2A is 3B plus 2. Look at the second equation now. If 2A is 3B plus 2, let me just substitute 2A. Why do I got to work with A by itself all the time? Why can't I work with 2A? And the answer is I can. As long as I can see it, I can do it. So that is a legitimate step to take. That was some good algebra right there. So that's how I'm doing it. Anyway, so 3B plus 5 equals 6B minus 1. Let me do some quick algebra there. B is equal to 2. And if B is equal to 2, 2A equals 6 plus 2. So 2A equals 8. Then A equals 4. So I found A and B, all right? So if I found A is 4, that means 2A is 8. That means EG is 16. Hopefully you got that. And let's see, 2A plus 3. 2A is 8, which means 11, so that's FH is 22. Ta-da! That's how fast you can be able to do these things if you know what you're doing. So when I said quick quiz, I was serious, man. Anyway, that's it for the lesson. It was a beast, but guess what we know? Parallelograms. I'm out!